Welcome to another video of capital budgeting. In this video, we'll look at an example of modified internal rate of return. Suppose that your company is considering two mutually exclusive projects X and Y, whose costs and cash flows are as shown below. So we have years and we have been given the costs and the cash flows for X and Y. The negative sign shows the cash outflow and the positive sign shows the cash inflows. The projects are equally risky and their cost of capital is 10%. Make a recommendation based on the modified IRR. So basically, in this example, we have to find out the modified IRR for project X and project Y. And whichever gives us a higher modified internal rate of return will be the recommended project. So let us first proceed with project X. So this is the representation of the cash flows for project X on a time scale. Now we know that MIRR is the rate at which the present value of the cash outflows will become equal to the present value of the terminal value of the cash inflows. So here let's first find out the terminal value of cash inflows. So basically what we have to do is to find the future value of these cash inflows. So the future value of these 200 rupees, let's say this is FV1. Future value of this 600 rupees is, let's say, FV2. The future value of this 100 rupees is FV3. And the future value of this 1400 rupees is, let's say, FV4. Now this future value is to be calculated on the cost of capital. So K is 10%. And once we add all these future values, basically what we get is the terminal value of all the cash inflows. So let's find the terminal value. So the terminal value is equal to, now we know from the formula of compound interest that A is equal to P into 1 plus I to the power N. Here A is the final amount at the end of the tenure. P is the amount which is being deposited at the beginning of the tenure. I is the rate of interest per compounding period and N is the number of compounding periods. Now in our context we can say this A is the future value, P is the present value, I is K, and N can be written as N1. So for the first cash inflow, we will say TV is equal to FV1 plus FV2 plus FV3 plus FV4, and the future value, it can be written as PV1 into 1 plus K to the power N1 plus PV2 into 1 plus K to the power N2 plus PV3 into 1 plus K to the power N3 plus PV4 into 1 plus K to the power N4. So this is equal to, now PV1 is 200. So 200 into 1 plus Now K is 10%, but when we use in the formula, we'll write it as 10 divided by 100. So this becomes 0.1. N is the number of compounding periods. So here 200 will be compounded for 1, 2, and 3 years. So N1 is 3 plus PV2 is 600 into bracket 1 plus 0.1 to the power 2 plus PV3 is 800 into bracket 1 plus 0.1 to the power 1 plus PV4 is 1400 into 1 plus 0.1 to the power N4, but this will not be compounded for any tenure because 1400 is being received at the end of the total tenure. So to the power 0. So this becomes 200 into 1.1 cube plus 600 into 1.1 square plus 800 into 1.1 plus 1400 into, this becomes 1.1 to the power 0, which becomes 1. So this is equal to 3272.2 rupees. So the terminal value of cash inflows is 3272.2 rupees. So we have the terminal value of cash inflows. Now we already have the present value of cash outflows because 2000 is in the present value form itself. Now we have to convert this terminal value into present value. And then equate the present value of the cash outflow and the present value of the terminal value of cash inflows. And the rate at which these two will become equal will be the modified internal rate of return. So let's see. So present value of cash outflows is 2000. So 2000 is equal to, now here I am not taking the negative sign because we are equating these two values. So we are saying that the outflow is equal to the present value of the terminal value of the inflows. If we want to consider the negative sign, what we can do is we can say present value of cash outflows plus the present value of terminal value of cash inflows is equal to 0. Now it is the same thing because the net of both these values will be 0 only when one is equal to the other and one has a negative sign and the other has a positive sign. So you can use that, or you can simply consider the absolute values of both equal to each other. So 2000 is equal to, now we have to find the present value of this amount at the rate of interest R. So present value, as we know from this formula, present value is equal to future value divided by 1 plus I to the power n. Here I is R and the future value is this value. So 3272.2 divided by 1 plus R to the power n, and n is 1, 2, 3, 4. 4. So or, now let's take this on the other side. So 1 plus R to the power 4 is equal to 3272.2 divided by 2000, or 1 plus R to the power 4 is equal to 1.6361, or 1 plus R is equal to 1.1309, or R is equal to 0.1309, or R is equal to 13.09%. So in case of project X, the modified internal rate of return is 13.09%. Now let's move to project Y. So this is the time scale representation of the cash flows for project Y. Again, the same thing for MIRR. We have to first find the terminal value of the cash inflows. So let's say this is FV1, FV2, FV3, and this one is FV4. So terminal value is equal to FV1 plus FV2 plus FV3 plus FV4. Now the future value will be calculated on the cost of capital. So this future value is present value 1 into 1 plus k to the power n1 plus present value 2 into 1 plus k to the power n2 plus present value 3 into 1 plus k to the power n3 plus PV4 into 1 plus k to the power n4. Now let's plug in the values. So PV1 is 2000. So 2000 into 1 plus k is 10%. However, while using in the formula, we have 10 divided by 100. So 0.1. So 0.1. Now N1 is the number of compounding periods. So for 2000, we'll have number of compounding periods as 1, 2, and 3. Plus PV2 is 200 into 1 plus 0.1 square plus 100 into 1 plus 0.1 to the power 1 plus PV4 is 100 into 1 plus 0.1 to the power 0. So this is equal to 2000 into 1.1 cube plus 200 into 1.1 square plus 100 into 1.1 plus 100 into 1. 1.1 to the power 0 will be 1. So this value comes out to be 3114. So the terminal value is equal to 3114 rupees. So this is in rupees. Now we already have the present value of cash outflows, which is 2000 rupees. We have the terminal value of cash inflows. So now we have to find the rate at which the present value of cash outflows will be equal to the present value of the terminal value of cash inflows. I want to point out one thing, that in this example, we only have one cash outflow, which is at the beginning or at the present value. However, let's say you had a cash outflow at the end of the second year. Now we have to find the present value of cash outflow. So the present value of that cash outflow will also be calculated at the cost of capital. So in other words, the present value of cash outflows and the terminal value of cash inflows will be calculated at the cost of capital. And then we'll equate the present value of the cash outflow to the present value of the terminal value of cash inflows at the rate which is the modified internal rate of return. So here let's find the modified internal rate of return. So present value of cash outflows is 2000. So 2000 is equal to present value of terminal value of cash inflows. So the future value is 3114 rupees. So 3114 divided by 1 plus R, that is the modified internal rate of return, to the power 1234. Or 1 plus R to the power 4 is equal to 3114 divided by 2000, or 1 plus R to the power 4 is equal to 1.557, or now we'll take the fourth root of both the sides. So 1 plus R is equal to 1.117, or R is equal to 0.117, or R is equal to 11.7%. Now this is for project Y, and earlier we had found the modified internal rate of return for project X, which was 13.09%. So definitely the modified internal rate of return for project X is greater than that of project Y. So since these two projects are mutually exclusive and only one of them can be added to the capital budget, we should recommend project X.